patterns, and this falls within the area of design, just like the lecture on software architectures that we had a while ago. In the middle of the lecture, we're going to take a break as usual, and I have what I think is a real treat for you. It should be cool. But no, before that, let's get through this stuff that's also cool, of course. So how do you design software? Well, you design it at multiple levels of abstraction or granularity. At the highest level of abstraction is your software architecture, or sometimes even system architecture. Why do you think software versus system? Why do you sometimes say system architecture?
Perhaps the system contains many different software architectures.
It may contain multiple software architectures, yes, but there's another reason why you don't always call it just software architecture.
It relies on something that's not software.
Well, what would that be?
Like, for example, say Uber, they rely on actual logistics and cars.
Okay, yes, Uber has more than software, but even if it's a software company, because something else.
Hardware.
Yes. For example, we may have components that run in hardware, load balancers and such. So anyway, that's a small point. So at the highest level of architecture, there's just how you put the pieces together: a web server, a web client. Then within the web server, the backend, we've learned about model view controllers and such. Those are architectures. Then you go to lower levels of abstraction, where you talk about how you put several classes together. And that's essentially what we're going to be talking today. And then at even smaller level of granularity is the design of a particular algorithm, the core, the kernel of one of your methods, okay? And that's not what we're going to be doing much in this class. So we rely on knowledge you've learned in other classes to design the algorithmic part. So what we're going to be describing today is how do you design, or what are these ways of designing the software at this kind of medium level of granularity. And in fact, we're going to do it through design patterns. What are design patterns? They are descriptions of how to put together a relatively small number of objects and classes so that you can solve a general design problem in a particular context. I did underline a few of the words in this definition, not because I want you to memorize the definition, but just to put it in context. It's more than one object. We're not talking about how to design a method or even a couple of methods. It's how do you design several objects together to do something. It's a general design problem. That's the value in a pattern. It's a recipe that you can use several times. It's not something you'll use once and then throw it away. And in fact, the way you achieve that is by customizing the recipe that you will see in this lecture or in reference manuals to your particular problem. Okay, so these are not full designs. There are more than one class. It's something that perhaps you haven't seen yet, and there are some useful recipes there that people have learned through experience, so why not? We should learn them. Let me explain advantages of using patterns, in case you're not convinced. Imagine a programmer that faces a certain design problem, need to achieve something to do X and Y, and you could design something that does X and Y from your basic algorithms, okay? Or you could use a recipe for it. That's kind of ready-made for X and Y. If you recognize that the behaviors X and Y are things that a particular recipe resolves. Okay, so one of the main benefits of design patterns is that they name common and successful ways to solve a problem. Some of them are simple patterns, patterns that you could reinvent yourself. If you were not aware, you skipped this lecture or forgot it or whatever, slept through it, you have problem X, you may be able to come up with exactly the same pattern. But there's value in just naming it in your code and in your communication, because it kind of enriches your vocabulary. You communicate more effectively with people when you name that I've used this pattern here. and then they understand what you mean. Okay, so it's a way to actually document the design of the module instead of describing it, how everything works together. You can just say, oh, I've used the bridge pattern here, and bridge pattern being a fairly commonly used pattern, people will know what you're talking about. You just have to describe how you customized it for a particular purpose. Okay? So it's a vocabulary thing. It's much easier to actually learn the architecture or the design of a component by design patterns than just by trying to read individual pieces of code. So that being said, my experience is that they have some common uses, but they are not going to constitute the majority of your code. The majority of your code, you'll still probably have to come up and design from scratch. But when you recognize, that these are uses for design patterns, you should use design patterns. Okay, we're going to be describing several design patterns in this lecture. Just like we've done for UML. UML is big, design patterns are a lot. Okay, we've done a little bit of UML. We're going to do a little bit of design patterns. The ones that I think come up most often. I picked an easy one to start with. I picked a very complicated yet very useful one to end the lecture with. And for each pattern, we're going to describe it by giving the name, although we're not going to be disclosing the name just yet. We're probably going to start with the problem. Here's something we're trying to solve. And then we're going to describe the solution, perhaps looking a little bit at what would be a naive solution for somebody who doesn't know the pattern, what they might invent first. Then we're going to give the pattern name, and then we're going to have some discussion about it. So that's the plan, and we're going to follow this plan 4 or 5 times over in this lecture. And we're going to do it in the context of a little program, fictitious program, that's a graphical text editor. So an editor with a graphical user interface. And this example, I didn't invent it. This is from a very classic textbook in software engineering. It's called Design Patterns, with 4 authors here, also called the Book of 4. And the whole book is structured as a sequence of patterns. I don't know how many they list here. Okay, Design Pattern Catalog starts at page 79, and it looks like about 30 patterns that they describe. Okay? And we're going to discuss 4 of these. So let me pass this along so that you can take a look at it. Most software engineering teams will have one of those books in the kitchen or somewhere in the library if they have one. Okay. What is this toy application that we're going to be playing with, this text editor? So you have to be editing text, and text is going to be made out of characters and words and lines and pages and columns and such, but we also want to be able to put graphics there, pictures. We will look at having some graphical elements of graphical user interface like toolbars and scroll bars. We'll complicate the problem by seeing how do you design it such that it can be ported easily to different look and feels, maybe even different GUI implementations, like to run on Mac versus Windows without changing most of the code. That's the kind of one kind of problem we'll be looking at, and we'll end up with operations on text like spell checking, find and replace and such. So how do we design the data structures and the object to do this efficiently? So let's start with the first design pattern, and as I said, we start with the problem, and then we'll look at the solution, we'll give the name, and we comment about it. The first problem is how do you even represent this document inside your program? What is the data structure? What do you have to represent? I kind of hinted before, but let me just elaborate. There's going to be some sort of a hierarchy of objects in this problem. We're going to have primitive glyphs. And I call them glyphs to kind of generalize the notion of a character. So that's the primitive glyph that forms words. But I can also have drawings, and including in pictures too. And they will play the same role as a character. You can put a picture next to a picture and so on, make a word with pictures if you want. I'm not going to really represent words as a particular, just a sequence of characters, but I will represent lines especially. Right? So they are a separate data structure for a line. And I will be packing primitive glyphs to make a line, and then I will be packing lines to make columns, and one or more columns will make a page. And then, of course, one or more pages will make the whole document. So, what would be a data structure that, actually, a picture first. So, in case you like images, this is how it's going to work. So, you have a column that has a sequence of lines, and then one of these lines or rows will have a sequence of glyphs. And it could be something like that. Okay? Well, how would you represent this? Any answers? I'm not, in fact, I'm looking for not the best solution now that can lead me into the design pattern. So, whatever comes to your mind.
It looks like there's a tree right in front of me. I'll take it.
Okay, good, good. I kind of wanted you to think like that. So, a tree data structure with internal nodes. But what would be the types of these nodes? What kind of classes would you invent here to represent this? Somebody else, maybe?
You gotta start with the primitives and work your way up. So you have your glyphs, then you have your row, then you have your column, and then your column's a page.
Okay, so you're going to have essentially at every level of this hierarchy a class, and a glyph class and several versions of it.
Race car class.
Say again?
Race car class, for sure. You gotta have that one.
Okay, good. A red race car. Then you're going to have a line class or a row class that has an array of glyphs. You have a column class that has an array of rows. Okay? That has a major advantage. The type checker will prevent you from making the columns out of glyphs, because you cannot have a column, has to have lines, and a line can have glyphs. So your program won't even allow you to construct a misformed data structure. That's an advantage, okay? Well, I'm kind of sneaking in another requirement in here, conveniently after I asked you to design. There will be some operations that I need to do on these elements that are similar at all levels of the hierarchy. For example, computing a bounding box. I have to be able to invoke a method on this race car and say, tell me what is the extent, width, and height of your window, of your appearance. And that might be useful when I'm deciding whether I'm clicking on you or not. Okay? And I want that for the car, and I want that for the line, and maybe for the page and all. Okay, so we're going to have multiple classes, but there's going to be some shared functionality. Shared functionality you can implement by the old and trusted method of copy and paste, always, or something else. Okay, so this was the actual design that you suggested. This is going to lead to some amount, perhaps a lot, of replicated functionality. For example, the mouse detection and so on. So here's an alternative design, which is leading me to one design pattern that I wanted to introduce. First, we create one abstract class that's going to embed all of the functionality that is pretty much common across all of the glyphs, at all levels of the hierarchy. And I'm going to call it glyph. And then I'm going to implement the classes that you mentioned, column, page, and so on, all as subclasses of glyph. Okay? So essentially, I'm trying to put all of the elements, not just the ones at the bottom level of the hierarchy, but even the ones in the intermediate, into kind of the same mold of a glyph. So there's going to be picture glyphs, and there's going to be line glyphs, and there's going to be column glyphs. So all of them have something that is special about them, but they also have some common parts about maybe detecting a mouse hit. So let me show you how you would write the code. And by the way, this is not supposed to be a deep pattern or a pattern that you could not have thought of. This is the simplest pattern I'm introducing. But it's a pattern nevertheless. So I define this superclass glyph, and it's going to have a children of other glyphs. Okay? The draw method is going to be inherited by all of the glyphs, and perhaps some of them will override it. But I'm going to write one here that will work for many glyphs. In fact, will work for all of the glyphs that are made out of smaller glyphs. And what do you do? How do you draw a glyph that's made out of smaller glyph? Well, you just iterate over your children and ask them to draw themselves on the screen. And this will probably work for columns, for lines, for pages, for documents. You will probably have this intersect. This is the mouse hit detection. This is the function that the mouse click handler will call with the coordinates of the click, asking you, does this click intersect you? Is this on top of you or not? So you're doing this kind of comparison of the given coordinates with your known position, width, and height. Okay? That's all it does. And then inserting a glyph, this is useful for the composite glyphs to add more glyphs to the children, to the list of glyphs. Okay? Any questions about this? Boringly simple code. Okay, good. This is just the superclass, and then I'm going to write these classes that he mentioned, but I'm going to make them subclasses of glyph, and conveniently, they're going to inherit much of this stuff. Now, character is going to be a primitive glyph, so it has no use of children. In fact, but it needs to know what the actual character is being drawn. It probably has a width and height and position. That will be needing. So the character constructor will be setting all these parameters. And for the drawing part, I didn't write it here how you draw a character, but it's going to be some other code. So we're not going to be using the inherited method. We're going to override the method for the atomic glyphs. And for the picture, the same. But the big bang for the buck we get, okay, picture is the same, sorry, like character. This is where it's becoming useful. All of the composite glyphs, they can inherit, draw, intersect, a lot of that other stuff. This is how, let me ask you if you have questions now. We'll look at the code example, and now we're going to look at how you draw this with UML. No questions. I'll let you absorb this diagram a little bit. So can somebody read for me this part here? This is the more delicate part. More people. I'm just working past this function. Okay, in the back.
Each glyph contains the amount of children.
Yes, each glyph can contain 0 or more children. And in fact, children is the name of the attribute that kind of holds them. Remember when we drawn last time the linked lists and the binary trees diagram? It looked just like that, except we replace this star with a 0, 1, 2, or 0 or 2 to say it's a binary tree. This is how you draw a tree with an arbitrary degree, arbitrary number of children. Okay, is that clear? So indeed, we have picked a tree data structure. The only thing that's different from the design that was proposed was that instead of having different types, the tree is built out, it's recursively, as far as the type system is concerned, you can build a tree of arbitrary depth here. While the design before, where the line had a list of atomic glyph children and the column had a list of lines, here all the composites have a list of glyphs. So in fact, as far as the type system is concerned, you could construct a nonsensical data structure here. You could have a line whose or a page whose children are glyphs, it should be columns. But we made the type system a little bit less enforcing, and we gained all of this inheritance here. We're inheriting the draw for most those classes. And in fact, most of the code in your system will only use the glyph, will be working with glyphs. It doesn't need to know how the glyphs are drawn, how they're intersecting. The glyphs, the subclasses will take care of that. All we need is to work with this. This is an advantage because we don't have to be writing all of our code. Oh, this is a column, this is a line. It's a glyph. Everything's a glyph. Any questions about this?
You said that means that we have 0 and many children, right?
Yes.
How come we have to have 1 and not 0? Because I didn't understand if 1 meant we had to have at least 1.
No, 1 is this end of the arrow. Star is that end of the arrow. So this means that, okay, reading from this, one glyph contains 0 more children. Each glyph is contained in exactly 1. Okay, so when you read the arrows in the 2 directions, and you read the different arities. Other questions? A good question.
What about the top level?
Good point. The top level you're saying is not containing anything. Yes, I guess this diagram does not really reflect that. Let me ask you another question. It's actually something I thought you might ask me. So what's the name of this design pattern? What do you think is the name of the design pattern? It's on the slide. It's composite. Yes. Oops. Okay, so this is a composite pattern, but it has other names as well. Different people might call it recursive composition because it has this recursive nature of glyphs inside structural induction, tree walk, whatever. This really predates the design pattern. So in fact, actually, what these people have done with design patterns, it's not like they invented this pattern. They've collected. This is a collection of folklore, of software engineering folklore. And they gave them names, they cataloged them, and they tried to separate them from each other. And that's what really it is. And it's true for most things. Okay, so moving on. Oh, actually, I have one more slide about advantages and disadvantages. There shouldn't be any surprise here. So the main advantage of this recursive composition, where you treat everything uniformly as glyph, is the main code of your application is written in terms of glyphs. You can sneak in a rectangle glyph by implementing a rectangle class and tying it in with a menu that draws a rectangle, sticking in a rectangle class in there, and you don't have to touch the rest of the application because the application works with glyphs, it's going to work with rectangles as well. Okay? It's very natural for hierarchical structures, and it leads to elegant code. You don't need to iterate over. You only write the iterate over the children once. You don't have to write separate for lines and columns. But there are disadvantages as well. So there might be aspects in your application that are not following this nice hierarchy. And as it's true with most design patterns, they solve 99% of the problem. The other 1% you may have to kind of bypass a little bit the pattern. You may have to adapt it or hack it, depending how it works. And I already mentioned the type system here. We kind of took away some information from the type system. The type system doesn't know anymore that the line, a column is supposed to have only line children. The type system will allow you to stick, the race car in place of a line. Okay, moving on. Design pattern number 2. We have about 5. This time we have a representation of our document. We want to try to enhance the user interface. And in what way? We want to be able to add borders, scroll bars, combinations of borders and scroll bars to columns, to pages, even to lines, if we so wish. What does it mean a border and a scroll bar together? Well, you may want to have a border line, and when the scroll bar to be outside of the border, right? You scroll the whole thing, or to have the scroll bar inside the border. I haven't really seen much of that, but just for the purpose of demonstration. So do you understand what I'm kind of trying to do? I even want a double border. So a border around the border. How would you incorporate this? And let's assume that this list is longer. Menus, knows what else. You want to put on every element, on lines, on columns, on pages, like a line number, a column number, a page number, numbering. Okay, it's kind of an open-ended question, but I'm sure you could do it if you were asked to. Let me propose one idea that I'm sure you would abandon pretty quickly. By the time you get to the end of the slide, you would think, oh, it's not so good. So we say, okay, we have these glyphs, and I want to create a subclass of a glyph that's a bordered glyph. So it would take whatever glyph it's bordering and draw a border around it and package it all up as a glyph. So it'd be a subclass of glyph, right? So you could construct a bordered glyph, and then everywhere a glyph is used, you could use a bordered glyph. Or a scrolled glyph, this would add a scroll bar. But you run into the difficulty here. If you want to put a border first and a scroll bar outside, what? Would you create this bordered and scroll glyphs? It starts to look funny. Or this is even funnier. And this is the other way of putting the scroll bar inside the border. So the problem that we have here is you're trying to use the class hierarchy to describe a concept that is not really static in your application. Static, generally, means something that's hard-coded in the text of your program. So the code of your methods is a static concept. Dynamic is something that can vary at runtime. So typically, the data structures that you're using are dynamic. Here, we're building this combination statically because we're writing code for these classes. There's only a finite number of these classes you can type in your program, and that's it. Well, that seems that it's not the right thing to do. So we need to look for a way to be able to add scroll bars and borders and combine them freely without having to write all of these combinations ourselves. We would like to do something of the following form. We will to define some scroll bar class and some border class, which can be used like this to put a border around the character glyph and put a scroll bar around that as well. And if you can write this, nothing prevents you for putting two scroll bars, a horizontal and a vertical one, and putting two borders or putting the borders outside of the scroll bar. Right? Because it's just a way of how you combine this code. Right? I'm not sure I got this through. Is it clear that this is a lot more flexible than defining a scroll bar border that you can apply on a character? Because the decision of what to pass here is something you do at runtime. You can put a conditional here. You can look in a configuration file to see if you add one border or two, and just write a loop of creating new borders. Okay, so this is a lot more powerful. And with n of these classes, you can create 2 to the n combinations by just calling them in different order. And this is done without repetitions. If you can repeat them, it's an infinite number of combinations. Not that you need that many, but it's just a cleaner design. Okay, so if you got this, let's see how you actually do this. So from here on, it's not a big surprise. We're going to define a notion of a decorator, which is a special kind of glyph. So a decorator can be applied, it applies a decoration on top of a glyph. And because it works on glyphs, you can decorate a line, a column, or a raised line. But furthermore, not only it decorates glyphs, a decorated glyph is also a glyph itself, which means it can be put in lines, in columns, in pages, and so on. So we're going to write a class border that extends decorator, scroll bar extends decorator, menu extends decorator, and decorator itself extends glyph. In terms of code, it's going to look a little bit like this. Is this big enough to be read from the back? Well, I guess if you sit in the back, you have good eyesight anyway. It's just adaptation. So decorator extends glyph, and pretty much this is the abstract class. This is not about a specific decorator. It just sets up the class hierarchy. So makes decorators, all decorators, a member of glyph, and a decorator stores a reference to the glyph it decorates. So you kind of interpose it. It takes a glyph, decorates it, makes another glyph out of it. And this is how you write the scroll bar decorator. Scroll bar extends decorator. When you construct a scroll bar, you have to pass a glyph to the constructor, which is simply going to call this setDecorated function to remember the reference to the glyph it decorates. And then you have to implement the glyph interface. When you draw a scroll bar, you first draw the object you are decorating. That allows you to get its extent, where it is on the page. And then you draw a scroll bar around it, wherever, horizontal, vertical. So this is very specific to this particular decorator. And, the border would be very similar, would start very similar. When you draw the object you need to put a border around, and then you draw the border. And if you can construct two borders on top of an object, each one will draw in turn a border. Okay, and in this way you get double border, triple border, whatever you want. Any questions so far? Yes.
Why even bother with the decorator class? Could you just have a glyph and a new glyph and make the do you want to decorate its child and then override draw?
Yeah, so essentially his question is, why do you need this abstract class? Why can't you just all do it here? Class scroll bar extends glyph, right? Then you'd have to remember this decorated field and then the same implementation here. I agree, it's a fine. I mean, you're saying let's save these 5 lines. The only thing these lines give you is this commonality of storing this field glyph. Otherwise, you'd have to do this all over again. It's not much. It might be okay. Probably I would follow that. I generally don't like classes that are just 10 lines long. It just adds noise. But anyway, the concept here would be the same. So this is how the UML diagram looks. Okay, take a minute to absorb this. Look at this pattern here. A decorator contains a glyph, and it's a glyph itself, which allows you to stick a decorator an arbitrary number of times at any level of your key hierarchy, and still fit it in the hierarchy because it's a glyph. And because it contains a glyph, it means you can take whatever low in the key hierarchy. These are two specific decorators. So I think going back to your design, this would change a little bit. These two would move to be subclasses of glyph, and would still contain this part. So border would contain a glyph, and scroll bar contains a glyph, and then each is a subclass of glyph, and that would work. Maybe it would look a little bit. This way, we kind of separate the decorator hierarchy from the actual glyph hierarchy by way of this decorator. So these are not attached. These are not subclasses of a glyph. They are subclasses of glyphs. It's at this point, maybe it's a taste question. Any question about this? You want to ask me now, what is the name of this pattern? Right? What is the name of this pattern? Decorator? Good. You're seeing patterns here. Okay, so just some comments for your reference at home. So the decorator contains glyph and extends glyph, and this is how can you recognize a decorator. So this is a way of adding responsibilities to an object and still maintaining its identity because you still inherit from its superclass. The good thing is, what I hope you understood from my initial motivation, is that you can add these decorations dynamically. based on configuration files, based on user selections and so on. Right? So it's very common to be used in conjunction with the composite when you have these trees, sticking these responsibilities in the middle of your trees. One more. We'll make 3, leave 2 for after the break. Okay? Hold on. Let's try now to suppose that we want to change the theming of your UI. And I know that you're playing with themes in your software. What I'm talking about here is something more substantial than just changing the style sheets, changing colors, and something that even changes the way things kind of react. Something that would require to write different code for different themes, not just change some configuration color. Okay, because that's what we're talking about here. How do you write code to achieve different things? But let's say that this is themes that change the appearance and maybe even the behavior of scroll bars, the menus, and such. And I want my editor to support them all without messing with most of the code. I want to have Sunny scroll bar and Pepper scroll bar. Sunny and Pepper are my 2 themes that I'll be using in this example. Okay, and I'll write this code for how a Sunny scroll bar behaves and how a Pepper scroll bar behaves. And I would like to write something like this. In the places in my application where I actually create a scroll bar, I want to write new Sunny scroll bar if some condition holds, otherwise a Pepper scroll bar. Because maybe I want to change these at runtime or at configuration time. But anyway, I don't want to hard code in my code that this is a Sunny scroll bar. Then it's very hard to change. Now, of course, this is one thing, this is one construct that is not allowed in most languages. Definitely not in statically typed languages. Essentially choosing dynamically the class that you instantiate. You cannot do this in Java. Java compiler will require you the name of a class after new, not an expression that evaluates a class. So what do? Well, of course, you don't want to be writing new Sunny scroll bar in your code because it's just too hard coded. You'd probably write something like this. If style is Sunny, then you create the Sunny scroll bar. Otherwise, if style is Pepper, then another scroll bar. And then if you have 5 themes, that's a problem. The problem is even bigger than it seems here. The problem is bigger because you may have multiple places in your code where you create a scroll bar. So you have to remember to put this everywhere. But even worse, what if your theme, it's not just the theme of your scroll bars. Everything has to change in lockstep. Menus, scroll bars, borders, little close buttons at the end. Then you have to be careful that when you change the style to Sunny, everything changes style to Sunny. Scroll bars, menus, stuff. So you're going to end up with a lot of this stuff. You don't want that. So that leads me to the need for abstracting or separating out the creation of objects. Let me go back to the previous slide. You see, I already wrote whatever is specific about the scroll bar in this class and whatever is specific about the Pepper in the Pepper scroll bar. All I need now is to hook these classes in the right places, to create the right classes whenever I need the scroll bar. So I need to somehow get more control over the object creation. Wherever I need to create the scroll bar, I want to have something that abstracts this mess. So I need to abstract the object creation. And, okay, what I'm going to do, I'm going to define a GUI factory class, which it's an abstract class, and I'll have each instance of this class knows how to create, for example, Sunny scroll bars, but not just scroll bars, menus and everything. Everything's Sunny. Then I'm going to have a Pepper factory, which will create everything Pepper. And then the one thing I have to do at the beginning of my application, or whatever I choose the style, the theme, is to pick which factory I'm using, and then use this factory throughout my application, and the factory will take care internally for creating the right things. So if this wasn't terribly or totally clear, let's look at an example. We're going to have this abstract class, GUI factory, and it's going to know how to create scroll bars, menus, everything that's its theme. And in one place in my application, I'm going to have something like this. If style is sunny, then I set this global factory reference to a sunny factory. A sunny factory, it's an instance of this, knows how to create scroll bars, menus, and everything, and all looking similar. Or a pepper factory, or everything else. So I do have this code. It's just I have it in one place in my code. That's what I achieved. So in my code throughout, when I want a scroll bar, I take the current factory reference and create scroll bar. And the code will contain a lot of this throughout. Also, menus. The same factory. Create menu. So first I choose the factory, and then I ask the factory to create the menus. Notice I don't use the new keyword anymore. That's going to be inside the factory. Okay? And this is an example of the Sunny factory. The Sunny factory, it's an instance of GUI factory. And it knows how to create scroll bars, but it will create the Sunny scroll bar. And the create menu will create the Sunny menu. And because the moment I choose this factory, everything created by it will be Sunny. And then I'm going to have another instance of this that's going to be your pepper factory. That will create everything pepper. So I've kind of separated things out. The conditional is here, the actual allocation is there. But it has the same effect as if you had written all of these all over the place. So you get the right behavior with cleaner code. Questions? Yes?
Can we pass Sunny or Pepper as an argument of this constructor, and depending on the constructor, initialize it?
Yes, you could. It would achieve a similar effect. So what he is saying is to create a GUI factory whose create scroll bar takes a style. Okay? And the implementation of create scroll bar will have to have this. And the implementation of create menu will also have to have this. So it's almost as good because you have maybe several instances of this, but they're all in one place, maybe not too bad. It might be acceptable. This is trying to go even better. Just have only one place, choose a factory. Once you pick the factory, no more conditionals on style.
But isn't that method slightly advantageous if you want to customize your factory? If you want to customize the look, like say you want the menu from Sunny, but you want like the scroll bar from Pepper.
Good point. If you want that, that's not the problem this factory solves. So you need maybe that kind of, but that's still a factory because you're kind of encapsulating the creation in one place as opposed to having this everywhere you need to create things. So different kinds of factories achieve different kinds of things. Any other questions?
Yeah. So this is a little simpler than DI, I guess, dependency injection. Is there anything else we would gain by using this over that?
Dependency injection. So that's a subject of a future lecture. Dependency injection also is a way to kind of customize the creation of objects. But I don't know how to answer that best. I think there's still value in knowing this factory pattern, but there might be systems that work that have decided from day on to use dependency injection, which essentially is another mechanism that gives you a way to customize the creation of things. Maybe you wouldn't use both factory and dependency injection. But I find that factory is used more frequently than dependency injection. Okay, so there's two sets of UML diagrams I want to show about the factory. One is the factory hierarchy. So there's this GUI factory abstract class, and it has several implementations. This one creates scroll bars, pepper scroll bars. However, notice that the return type of create scroll bar, it's not pepper scroll bar, it's not Sunny scroll bar, it's scroll bar. So you also need a hierarchy, kind of a similar hierarchy of the products of the factory. So that's the factory that creates the products, and these are the products that are created. Scroll bars, menus, they're all decorators, and there are several kinds of products. So this is called a factory pattern, and you use it when you want to do something special whenever an object of a certain kind is created. I showed you when you want to choose different implementation, but sometimes maybe all you want is to count how many objects are created. Then instead of letting people call new all over the place, you create this factory that will do the new for you and will do this additional work that might be needed. Any question? No questions. Ready for the break? I am ready for the break, so I'll take the break. I'm going to set up a really cool demo while you're stretching for a minute or two. Yes?
Question about the fuzz. When we're ready,
It's somewhat in the spirit of the last one where we used the factory to support different themes. But different, I actually want to have different implementation of very basic operations. I want to run my application on Mac and on Windows. Most of the code that got to my application are the same. But the code that draws anything on the screen has to use Win32 APIs for Windows, has to use Mac Cocoa API for drawing. Very, very different. Okay? And these are big APIs, drawing lines, windows, circles, all sorts of stuff. So you have to really do it in a very systematic way, or else it's going to be a mess. Your first thought might be to say, I'm going to make my application use only features that exist in all of the window APIs to which I want to run, and perhaps with different names, and then I can support all of them. So essentially, we're going to use a feature in our GUI model. GUI model is this abstraction that we have for the actual GUI library, and our model will only support stuff that exists everywhere. But that's going to be pretty restrictive, because if you take the intersection of several windowing systems, there's very little that they all do the same way. So what we're going to do is we're going to build a bridge. We're going to construct a bridge, an abstraction bridge, between our application and the actual Windows API. And in fact, this pattern is going to be called the bridge pattern. And it's a very common way to implement portability. For example, I use it in my application to, actually not even my application, let's talk Django, let's talk Rails. In Rails, Rails has a bridge to your database, because you don't write MySQL or Postgres code in Rails. It will take care of using Postgres or SQL. So that's a bridge in there in Rails. A big one, but you can sometimes have bridges in your application. If you're going to use multiple authentication systems, you want to put a bridge in there so that you can switch them on. So this is how it's going to look. So this is going to be a little bit loaded, this slide here. I'm going to have an abstract class window, and all of my application will use this class. It's a very generic name: draw rectangle, draw character, draw circle. And even I can have subclasses, an application window, an icon window, dialog box window, and everything is in terms of window. The window internally, inside, will have a reference called window implementation. So this impl, it's a common convention for this pattern. It's sometimes called the impl pattern, because you have the abstract class that has a reference to the actual implementation. And then I have this window implementation class that has multiple implementations of the implementation class. There's one for Mac, and there's one for Windows, and one for X window. And in here, I have a lot of Mac-specific Cocoa code, or X window code, or Win32 code. But I make them all bridge, make them all implement this kind of interface. So essentially, I have two class hierarchies. This is the abstraction which abstracts away from the details of implementation. This is the implementation hierarchy. And for example, this window draw rectangle may be implemented like this. Essentially, it's going to be referring to this implementation class draw line, which at runtime will go and find the proper implementation that it's using currently, and it's invoke this draw line, and then or this draw line, depending on how the system is configured to run on a Mac or a Windows. Okay. So what I'm saying here is I'm separating out the abstraction, the model, from the implementation. So if you build a bridge for authentication, you're probably going to have one of these classes that say authenticate or log out, sign out, whatever. You're going to have several implementations of that, whether you're using Facebook authentication and Google API authentication. And then inside your application, all you're going to be calling is this kind of abstract authenticate in that case, or draw a line in this case. Okay? So this is called the bridge pattern or the impo pattern, and it is put in place when you want to separate out of your application details that you think you may want to change. And again, when I touched on the tool that I told you about that I built, uses Django, but I'm not using its relational object model. So I'm not using its database part in Django because I use a Redis database, which is not relational. I wanted to use a Redis database with Django, so I built my own bridge. Instead of sprinkling Redis commands throughout my code is written in terms of high-level database operation, like look up a hash value or union two sets. And I have a Redis implementation of that bridge. Perhaps one day I will have another implementation of that bridge. In fact, let me take that back. Even today I have two implementations of that bridge. I have a Redis implementation of my database, and I have an in-memory quick hack that simulates the database. I use that for tests. The tests run 1,000 times faster if I don't hit the database. Even though Redis is extremely fast, in-memory hash table, it's even faster. So it's actually a very, very useful pattern. Maybe you won't be using it from day one. It does take some foresight of saying, okay, I don't want my application to depend on details of the Google API. I want to separate that out, put a bridge. Sometimes you do that in state iteration 2, iteration 3, when somebody comes with the idea, well, let's add Facebook authentication as an alternative. That's when you refactor the code to put a bridge in place. Do you have any questions? No questions. Okay. Did I put you to sleep in just 10 minutes? Because you were awake at the end of that bash. Okay, we're almost done. We're done for today, but we're almost done with this set of slides on design patterns. There's one left that's a very important pattern. It's also non-obvious patterns. Maybe this one you could have invented on your own. That one, it's equally useful, but non-obvious. We'll do that first thing next lecture. Yes?
Is bridge pattern also used in like browser or like mobile?
I'm pretty sure it's used a lot. Whenever you want to separate your application from implementation details, you use one of these info patterns. Separate implementation out. Thank you. There's a deadline tonight. There's a quiz, right? And we're going to have another quiz out tomorrow morning about design patterns.
That it wasn't.